Hello everybody, my name is Haya Altaleb from Obada University, the Doctoral School on Safety and Security Science. I'm presenting this paper with the title SCADA System Protection Against Attacks for the Smart, Sustainable and Safe Cities Conference 2022. The content of this presentation is about introduction about SCADA networks, attacks on SCADA networks, and more blocking attacks with a SCADA firewall using virtual closed network, the SCADA protocols, as well as the SCADA critical infrastructure. The use of a SCADA system is anticipated to reach 300 million euros by 2020, necessitating more sophisticated control and monitoring to find unplanned and unknown events. To enable the complex tracking of interconnected and integrated systems, it's necessary to design high-end SCADA systems that meet the specification of the next generation of architectures. The commercial manufacturers have to enable their firewalls capabilities to handle the SCADA protocols or to create a SCADA-specific firewalls, although the open source firewalls are utilized effectively. SCADA networks. The SCADA systems are frequently elaborate networks with numerous components, and these systems are sorted into three types depending on the operators. They can be found as fully automated by the machines and software, fully manual by human engineers and technicians, or hybrid, in which part control is handled automatically and some are performed manually. To accomplish all of these tasks, an enormous SCADA system contains 5 parts. The first one is the field interface devices, which is the local control devices, including the valve, actuator, motor controllers, and the control switch boxes, sensor reporting and detecting power levels, the flow rates, and the pressure and the temperature. Operating equipment such as the SCADA networks control the motors, the pump, the factory automated systems, and valves. So the rest parts are the control PCs, the management PCs, and the network communication. The control PCs is an embedded computer or specialized PCs that manage systems and control the associated operational equipment. And these computers may automatically make decisions depending on sensor data or they may relay commands from the management computers. The management PCs is the terminal with the HMI, it's the human machine interface, and these computers provide operators with an interface for monitoring and controlling the SCADA network devices. The network communication local remote. The SCADA network employs several communication methods. The short-range communication utilizes serial communication, USB and custom wired network, the Ethernet, the TCP/IP, the Wi-Fi, the TL-up network, and the cellular packet data and other protocols are utilized for the long-distance communication. In addition, the SCADA network increasingly employ the internet for the long-distance communication and remote access, which make it more open to cyber attacks. Modern control centers are equipped with the data servers, the HMI stations, and additional servers to aid operators in managing the factory network. Typically, this SCADA network is linked to an external corporate network and the World Wide Web via specialized gateway. The gateway serves as the interface between the IP-based network on the factory floor and the field bus protocol past SCADA networks. The gateway provides the mechanism for the protocol conversion that enable communication between two distant networks. Moreover, it gives It gives the cache mechanism for the data objective exchange between network to improve gateway performance. So the figure 1 illustrates a typical SCADA network example. Attacks on SCADA networks. There are a slight disagreement that the SCADA network required enhanced protection. So the most reported SCADA system attacks include the manufacturing plant shutdown, the train system delay, and the discredited former employee triggered and the sewage system spillage. Blocking attacks with a SCADA firewall using a virtual closed network. The SCADA firewall may be utilized to protect the remote devices without altering the SCADA system itself. It may also be used to preserve the SCADA equipment deployed on the factory floor or in another non-remote location. The future of SCADA equipment might be protected by firewall software. The SCADA firewall should offer a device's ability to control the packets it processes, defending against the cyber attacks launched over the internet to the office network or the Wi-Fi networks, enhance the security against denial of service and packet floats, capability to identify and report unusual traffic, propose and assaults, the capability to oversee and regulate the filtering policy changes. According to the AGA 12 standard of the American Gas Association, there are between 150 and 200 SCADA protocols. The majority of these protocols were individual company-developed probability standard, and the industry has shifted over the years accept common open standard protocols. Even with the open protocols, there are enormous professional groups strive to increase industry acceptance for their respective protocol standards. The protocols shown in Table 1 are among the most popular and commonly utilized. As we can see, there are 7 kind of most known protocols, the organizations that release these protocols, and the main feature of them. As indicated in Figure 2, the evaluation of architecture may be further subdivided into 4 prior generations based on their functional capabilities. The first generation consists of conventional SCADA system with a remote terminal unit, the RTUs. With the arrival of the distributed systems, the second generation was born, in which the RTUs were connected into the interaction servers through the WAN. The introduction of a new equipment suppliers on the market, the industrial expansion, and its rise in automated process necessitated the development of the networked SCADA systems, also known as the third generation SCADA systems. IoT and the cloud play a significant role on the fourth generation. The IoT refers to various devices and sensors that gather data from remote areas and are linked to the SCADA master via wireless LANs. The obtained data is then transferred to the cloud for further processing. In addition to being simple to manage and integrate, these systems offer more rapid information, scalability, availability, efficiency, and cost benefits. So as a conclusion, the SCADA-based CIS have a significant cybersecurity problem, and these systems are continuously exposed to greater risk. In addition to environmental risk, the security mechanism of the CI must be able to withstand sophisticated cyber attacks. The SCADA-based CIS with a suboptimal security measures may experience cascade failure and reconstructing from scratch impractical. Consequently, it is obligatory to consist of and create the lightweight security mechanism that suit the current and evolving security requirement for the CIS. Thank you so much for listening. And if you have any question, please reach me out by my email. Thank you so much and have a nice day.